So let's talk about standing waves in air column. So this is a bit similar to standing waves, the normal standing wave we have been doing so far, but only that in this case you are going to have a wave in air column. Let's say you have a pipe. Okay, if this happen to be the pipe, so if a wave is going to be generated here, so now here is going, we are going to have two cases. So have the first part which we are going to talk about is the pipe opened at both ends. At both ends. Let me just put it here. So the pipe is open at both ends. Pipe open at both ends. So, and then a wave is going to be generated like that. Okay. So again, the length will not change. The length of the pipe will be the same. It's the same as standing wave. The length doesn't change. So now we know that this is the antinode and this is the node. Okay. So now what we need to understand is that if I add this part here and that part together, they will make a half wavelength like that. Okay. So in this case, if the pipe is open at both ends, meaning this part only is half a wavelength, is 1/4, is quarter, is 1/4 a wavelength, even that one is 1/4 a wavelength, meaning that this length is the addition. We need to add 1/4 plus 1/4, which is going to be L. In this case will be half. If I add 1/4 plus 1/4, the denominator is the same, we add the numerator 2/4, which is 1/2. So have half a wavelength. So now this is totally different from the normal standing wave which we've been doing so far, because in this case we have got one node, okay, and then we have got two antinodes. Node is 1, then we have got antinode which is 2. So now if I have another one, let's say we have two of these, like that, it is open, meaning that we know that this is 1/2, this is 1/4, this is 1/4. So again, this and that is going to give me half. So half plus half is 1. So you discover that this is going to be 2 over, it's the same as just 2/2. Okay, or it's the same as it's going to be L is equal to lambda, like that. So now one thing we need to understand now is that we are going to have, if I have got 4 nodes, if I have got 1, 2, 3, then I've got, okay, let's start with the 3 one. So it is open at both ends. You are going to see that what we are going to have is going to be, this part is 1/4, this is half, this is half, and this is 1/4. So 1/4 plus 1/4 is going to give me half. Half, this is, it's the same as I have got half plus half, again half, because 1/4 plus 1/4 is half. I'll end up having 3/2. So you discover to say the only difference with the normal standing wave is the node and the antinode, but we'll still have the same. So we'll still have n to be equal to 1, 2, 3, 4, 5. They'll keep on going. So now in this case, what we need to understand is that if the pipe is open at both ends, we'll still have the same. We'll have node is equal to 1, antinode is equal to what? So the formula now is going to change. It's going to be node is going to be equal to the antinode minus 1. Then the antinode is going to be the node plus 1. But when we're doing the normal, if the pipe is closed at both ends, it is opposite. Node is equal to antinode plus 1. Okay? So now in this case, meaning this one is going to be lambda to be equal to 3 over 2, or L is equal to 3 over 2 lambda. Now, let's go ahead and now derive the formulas for the fundamental frequency. So like we said earlier, if n is equal to 1, we're talking about the first overtone, which is the first fundamental frequency. If n is equal to 1, 2, 3, or 4, we're talking about 1, the first fundamental frequency, second, third, fourth. Okay? So now I can make lambda as a subject of formula. So the general formula will be the same. N divided by 2 times lambda. When n is equal to 1, we're talking about the first fundamental frequency. So I can make lambda as a subject of formula. So in this case, we'll still have 2L divided by n. So this formula will be the same as the one for normal standing wave. But the only thing is the antinode is going to be different now. It's the opposite of the node. What do I mean? If I've got 3 antinode, if I've got 2 antinode, I expect to have 1 node. If I've got 3 antinode, I expect to have 2 nodes. Okay? Now, what we have to understand now is this. Okay? The fundamental frequency will be the same thing. So remember we said V is equal to F. Now in this case I don't know the F I'm talking about, so I'll say Fn lambda n. Let's make Fn as a subject of formula. Fn will be equal to V divided by lambda n. We can replace lambda with this. So this will be equal to V divided by lambda n. Or lambda n, we are going to replace it with 2L divided by n, like that. The pipe is open at both ends. So we have Fn to be equal to V times n divided by 2L. So this will be NV divided by 2L, like that. So that is the formula now for any fundamental frequency. So if n is equal to 1, if n is equal to 1, we'll have 1 times V is V divided by 2L. If n is equal to 2, we'll have 2 over 2V divided by 2L. If n is equal to 3, we'll have the same, 3V divided by 2L. So I want you to see the trend which is happening there. V over 2L, V over 2L, V over 2L. Therefore, we can clearly see that this can be given as, I can isolate n to be here, then I say V divided by 2L. So V divided by 2L is the first fundamental frequency. So that's why we are going to see this formula now. So this formula is also important. We derive this formula when we're talking about the normal standing wave. So it's the same thing. So now, in this case, when the pipe is open at both ends, we are following the natural numbers. Okay, so you always have what we call the natural frequency. So you have, we follow the natural numbers. What do I mean? N is equal to the natural numbers. So we call it as natural frequency. You always have natural frequency because the pipe is open at both ends. So the only formulas which I want you to be familiar with are L is given by n divided by 2 times lambda. then lambda n is given by 2L divided by n. Then the frequency n is given by this. Then also this can also be given by nf1. Sometimes they can give you the mass and the tension force of the string. Then you need to remember that V can also be given by the square root of the force divided by mu value. Remember we said mu is equal to the mass divided by the length. So then we can say the Fn can be given by n divided by 2L times V. Where there is V, let's put now the square root of F divided by mu. So this is also very important. Okay, now that is it when we're talking about a pipe opened at both ends. So the only difference with the normal standing wave is only the nodes and the antinode. So like we said, the normal standing wave, we are saying the node is equal to the antinode plus 1, but here the node is equal to the antinode minus 1, and the opposite is true. Now let's talk about the pipe open at just one end. So pipe open at one end. So if I've got a pipe and this pipe is open at just one end, so what does it mean? If this side is closed, then it comes as that. Okay. So one thing we have to remember is that this is the antinode, this is the node. Okay. Now since we know that this is just 1/4, so the length from there to there, the length is the same, it doesn't change. So what will be the length in terms of the lambda? So L will be equal to just 1/4. Okay. Now what if it is opened and then we have something like this? Okay, like that. So we know that this is 1/4 and this is half. So the length will be given by, so I'll say 1/4 plus 1/2. The common denominator is 4. So here I'll have 1, then here I'll have 2. So it will be 3/4. So I'll have 3/4 lambda. What if we have a different one? 1, 2, 3. So I'll have this. So this is 1/4, this is 1/2, this is 1/2. As long as it is open at one end, it's 1/4. Okay, it is 1/4. And then what we have to understand now is it's going to be 1/4 plus 1/2 plus 1/2, like that. So we are going to have the common denominator is 4. So 2, 4 there, I'm going to have 1 plus 2 into 2 is going to be 2, again plus 2. So I'll end up having 5/4. So now I'll say L is equal to 5/4 lambda. So I'm going to have L is equal to 5/4 lambda. So now what is going to happen now is I can clearly see that as we go on, the denominator will not change. Okay, the denominator will not change, but the only thing is going to change is the numerator. So we have got 1 at first, the second one is 3, then the third one is 5. So it's 1, 3, 4, or 1, 3, 5, 7. So we can conclude that n should be, when the pipe is open at just one end, n can only be odd number. So if you know the odd numbers, then you know that n should be odd number. So in this case, we'll only be dealing with the what? The odd frequency. So n can only be 1, 3, 5, 7. Yeah. then you keep on going like that. So now from here I'm going to 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 have my general formula to be n divided by 2 times lambda, where n can only be the odd number. N is equal to 1, 3, 5, 7. Then we keep on going. So now in this case we expect to have, when the pipe is open at just one end, then we expect to have the first fundamental frequency, the third fundamental frequency, the fifth fundamental frequency, and the seventh. You keep on going like that, the odd numbers only. So now let's go ahead and now derive the formulas. Okay, so if n is equal to 1, what will be the formula for frequency? Let's see. If n is equal to 1, so let's just write this: n over 4 times lambda n, meaning lambda n will be equal to, if I make lambda as a subject of formula, 4L divided by n, like that. So V is given by frequency n times lambda n. Let's make frequency as a subject of formula. Frequency n will be equal to V divided by lambda n. Where there is lambda, let's replace it by this. So Fn will be equal to V divided by 4L divided by n. That is the same as n times V divided by 4L. So this is the formula now for the fundamental frequency. So if n is equal to 1, if n is equal to 1, we'll have this. Then if n is equal to 2, we'll have 2V divided by 4L. If n, no, it can't be 2. Sorry. N can only be odd numbers. So if n is equal to 3, then you have 3V divided by 4L. Then if n is equal to 5, we'll have 5V divided by 4L. So you see that one thing here doesn't change. The only thing, this doesn't change. This part here, which I'm going to highlight in white, it doesn't change. So we can write the general formula to say F n will be equal to n times this, in the brackets, V divided by 4L. So V divided by 4L is the first fundamental frequency. So Fn can begin by n times this. This is also true. Where n can only be 1, 3, 5, 7. You keep on going, the odd numbers. Now, if you want to find the fifth fundamental frequency, you have the first fundamental frequency. So it will be just be like this. You plug in the values. So this is what you need to know when you're talking about the fundamental frequency. What if they ask you about the position of the node and the antinode? Okay. So if they ask you about the position of the node and the antinode, and then they are going to give you, let's assume to say n is equal to 3. So if n is equal to 3, meaning I've got 3 loops. Okay. If n is equal to 3, meaning we have got how many loops? We have got 3 loops. So let's see. In this case, if n is equal to 3, we know that n is the same as the antinode. Okay. So if n is equal to 3, then what should we know? We are going to say we'll have 1, 2, like that. So let's say it is open at just one end. Okay. So how many loops do we have? We have 2 here. Or let me just give you an example of when n is equal to 2. N can't be equal to 2. N can only be equal to 3. Why are we saying? Because this is 1 over 4, this is half. So we said 1 over 4 plus half will end up having a 3 over 4. So in this case, n is equal to 3. So when n is equal to 3, when we're talking about the standing wave, when it is open at just one end, when n is equal to 3, meaning the orientation of the diagram will be like that. When n is equal to 5, then we'll have 1, 2, 3, like that. okay, because this is 1 over 4, this is half, and this is half. So if we add, we end up having 5 over 4, meaning n is equal to 5. So when n is equal to 5, meaning we have got 3 loops in this case. Okay, so that is what you need to know. Now if they ask you to the position of the node, so you find that, you also find that, and that. Then the position of antinode, it will be that one, that one, that one. Now here is going to be 1 over 4 lambda. Then here you come there, yeah, you keep on going just like that. So this is what you need to know when it comes for the standing wave in air column. So let's try to solve some few questions. So the first question which I have is, a pipe is 2.46 meters long. Determine the frequencies of the first 3 harmonic if the pipe is open at both ends. Take the velocity as 343 meters per second at the speed of sound in air. Then part B, how many harmonic frequency of this pipe lies in the audible range from 20 Hz to 20,000 Hz. Then part C is saying, what are the 3 lowest possible frequency if the pipe is closed at one end and open at the other end? Okay, so now let's go ahead and gather our data. So from the information we have, so my length, I've been given that the length is 2.46 meters. What else? The velocity is 343 meters per second, and we want to find the frequency. We have been told that we need to find the first 3 harmonic if the pipe is open at both ends. If the pipe is open at both ends, so we're talking about 3 harmonic, meaning we're going to have this. I'll have 1, 2, so I'll have this like that. So it is open at both ends. So in this case, n is equal to 3, because this is 1 over 4, this is 1 over 2, and this is 1 over, this is 1 over 4. So is it going to give you us 3? So 3 harmonic. So if I add 1 over 2, that is going to be 1 over 2. 1, no, it's not the 1. So we need to add another one. So this is how you know now. So if we're talking about they are open at both ends, and then we want to see, I'll have that point and that point, 1 over 2. So it is open at both ends, then 1 over 4. So n has to be equal to 3. So I'll have 1 over 2 plus 1 over 2 plus then 1 over 4 plus 1 over 4 is this. Yes, so this is now 3 over 2. This is when n is equal to 3. So when n is equal to 3, we want to find the fundamental frequency. Okay. So remember we said the fundamental frequency is given by NV divided by 2L. So we want to find the first fundamental frequency, the first 3. So n is equal to 1, then the velocity is 443, 2, the length is 2.46. So the first fundamental frequency will be 343 divided by, open brackets, 2 times 2.46. I'll get 69.7. 69.7 Hertz. For the second one, if you want, you can keep using the same one. You just put 2 here. Then the third one, you put 3. Because when it is open at both ends, n can be any number as long as it's a natural number. But here I'm going to use this. So this will be now 2. The first one is 69.7. So the second fundamental frequency will be equal to 139. So we have 69.7 times 2. 139. 139.4. Then the third one, I need just to put 3 here. 69.7, like that. So it will be 3 times 69.7, 209 hertz. That is the third one. Now the next question is saying how many harmonic frequency of this pipe lies in the audible range from 20,000 hertz to 20 hertz to 20,000 hertz. So we want to find n. In short, they want us to find the value of n. So to find the value of n in this case, if we want this to be in the audible range, we have to say Fn will be equal to n times v divided by 2l. Our goal is to find the value of n. Let's make n as a subject of m. Now, which frequency are we going to use in this case? The frequency we are going to use is 20,000 hertz, because that is how audible it is. That is 20,000. The 20 is just the starting point, but where it is ending is at 20,000. That's why I'm going to use 20,000. So I'll say a 20,000 is equal to n, the velocity 343, to the L is 2.46. So if we cross multiply, we have n times 343. Then these two have 2 times 2.46, 4.92 times a 20,000. I'm getting 98,400. Divide this by 343. N will be equal to, I divide this by 343, 286. So 286.9, I can just say 287. So n has to be 287 for us to reach at the audible range. Okay. Then what are the 3 lowest possible frequency if the pipe is closed at one end? So if the pipe is closed at one end, remember the formulas we came up with. If the pipe is closed at one end, n can only be natural number 1, 3, 5. So these will be the first 3 lowest. Okay, so I'll say Fn will be equal to, we said NV divided by 4L. So the first one will be 1 times 343 divided by 4. Then here will be 2.46. The length will not change. So the first frequency will be 343 divided by 4, open brackets, 4 times 2.46. That is 34.86 hertz. That is the first one. Okay, that is the first one. Now we said that if you have the first one, then you can use the simple formula, which is the second one will be this formula. Fn is equal to nF1. So the second one will be the third one in this case. So it will be 3 times 3, 34.86. The third harmonic will be this times 3, which is 104. 104.75, so I can just say it is 104.57 hertz. So that will be the third one. Then to find this another one, which is going to be the fifth one, it's going to be 5 times the first one, which is 34.86. So it will be 5 times 34.86. That is 174. 0.3 hertz. That is the third harmonic, the fifth, sorry. Now that is it for this question.